Hey guys, welcome back to another video. In this video we are going to talk about how to find all roots. So it's just a continuation of the last one. So we're going to be given a polynomial and a root. We're going to divide by the given root, the one that they say. We'll divide it. We can do synthetic division if it is a whole number root, an integer root. We can just do synthetic division, make it super easy, and then whatever's left once we divide that off, you solve that remaining polynomial and get the rest of the roots. So here we have a polynomial 3x cubed, and then we're given one root. We're given a root is -3. So like I said, we will do synthetic division by that first root as long as it's something you can do synthetic division with. I would avoid fractions, or if it's crazy like a complex number or an imaginary number or a square root or anything like that, I would avoid that. Just stick with integers. And then you put your coefficients in here. Nothing's missing. And then synthetic division. So add, multiply, add, multiply, add, multiply. No remainder, that's what we're looking for right there, because it was a root. No remainder means it is a 0 or a root. Those words are synonymous. So then we're going to take the remainder. This is a 7 before I mistake it for a different number. We're going to take, not the remainder, but the remaining polynomial, our answer here, put the powers back on it, and solve that out. So this is a quadratic. It's got a 3 in the front. It's got a 3 of a leading coefficient, so we can try to factor this. I think it's factorable. If it is factorable, you'd multiply the 3 to the 20, which would be 60. We're trying to come up with some numbers that multiply to be 60 and add to be 7. What could that be? 10 and 6? Nope. How about 12 times 5? Yeah, that can get 7. So it's going to be 12 and 5. -12, +5. And then this trick that I'm using here is called splitting the middle term. 12 and 5, -12, +5 makes 7. So we're splitting that up, and then we do factor by grouping here. We can take out a 3x. And then here we can take out a 5. Uh-oh, I think I messed up here. Hold on a second. Yep, I just wrote the 60 there, and I didn't mean to. I wanted to keep the -20. So we keep that as a -20. I just meant to write off that -60 for a moment, and then I messed myself up because I wrote it in the wrong spot. So 20 factoring out of 5, that's a 4. Now these match. That's how I knew I had messed up, because those were not going to match the way it was. But those do match. So that's x minus 4, and then 3x plus 5. We're solving that out the rest of the way, which means x equals 4 and 3x equals -5. I'll do it in 2 steps. -5 over 3. So all of the roots, those would be x equals, you should list them in order least to greatest, but our answers are -3, 4, and -5/3. So -3 is the smallest, then -5/3, and then 4. Should list them out least to greatest, and in these little braces here. That's the best way to write them all out. Alright, here we've got another one. We're given a root, so we're going to do synthetic division with it. Make sure we're not missing anything. Nope, everything's there, so write down our coefficients. and then add and multiply for synthetic division. And again, we got a 0 remainder, which is what we wanted. Put our variables back into this, and we're going to solve that out. So again, we can solve this by factoring. Multiplying that 5 to the 1 is 5. We need numbers that multiply to be 5 and add to be 6. So we split that -6 into -5, -1, and then we can factor by grouping. To get the -1 here. Our parentheses match, so that's a factor. And then 5x minus 1 is the other factor. So we get x equals 1 and x equals 1/5. And then our given answer was -5. So when we write this out with the braces, least to greatest, the -5 goes first, then the 1/5, then the 1. There it is. So that's the idea. Again, you divide by the root that you are starting with, the first one that they tell you, and then solve whatever's left. These next examples get a little bit trickier, but you still start the same. Synthetic division with 2. No powers are missing. And we add, whoops, getting ahead of myself, add and then multiply, add and then multiply, add and then multiply, and we get a 0 at the end, which is what we wanted. Put it back our powers or our variables. And now this is not factorable because nothing multiplies to be 5 and adds to be 10. If it's not factorable, you just do quadratic formula, which, in case you need the refresher, -b plus or minus a square root b squared minus 4ac all over 2a. So with our quadratic formula here, -b, so that's -10. Plus or minus the square root b squared, that's 10 squared is 100, minus 4ac, 4 times 1 times 5, that's 20, all over 2a. 2 times 1 is 2. So let's start simplifying. And then simplify this 80. Try to come up with a perfect square that goes into it. 4 goes into it, but so does 16. 80 is 16 times 5. So if you think of that as 16 times 5, we can simplify this. Square root of 16 is 4. Square root of 5 is the square root of 5. And then now you can just reduce this fraction. So since all 3 numbers, we ignore the square root number, but the other ones can all be divided by 2, we can do that. So that'd be -5 plus or minus 2 square root of 5, and then 2 divided by 2, no more denominator. So there's 2 of our answers, and x equals 2 was the other one. Again, we can put these together. You can write these the same way, plus or minus 2 square root of 5. You don't have to pull it apart. You don't need to separate it to the plus and the minus separately. What was our other number? 2. And we can put the 2 there. That's okay to do it just like that. All right, we'll do one more example just to make sure. Again, synthetic division. Put your coefficients. Nothing is missing. add and multiply. We got a 0 at the end, which is what we wanted. That means it worked. -2 is a root. We were told it was a root. Put back your powers and solve this out. Put back your variables. Again, not factorable, so we're doing quadratic formula. -b plus or minus the square root of b squared minus 4ac. So that's -4 times 1 is -4 times -2 is +8 all over 2a. 2 times 1 is 2. So let's add that up. That's 57. 57 does not have a perfect square that goes into it. It's only 3 times 19. Those are both prime numbers, so there's no simplifying there at all. So we've got -2 and then this crazy fraction that we've got to keep it written as. So we can say x equals, we'll do our braces, -7 plus or minus the square root of 57 over 2, and -2 is our other one there. That's it. Just write out your answers, find all the roots. One of the things we're going to look at going forward is that since this was x cubed, we're looking for 3 answers. All of our examples today were x cubed, so they all had 3 answers. The given and then the 2 new ones that we've solved. We're going to look more at that in our next lessons coming up. So complete the worksheet, get it submitted, and post your comments and questions. See you guys next time.